computing center, and it costs a lot. So for this friend, it's quite different. They need a simulation model, and the period can be shortened. Now, in their new electric model cars, there is a data card by default. So each month, 100 giga data will be moved to the cloud, and the car center needs to do the calculation and see if there is any possibility of optimization. You know that in the past, when we bought a car, we basically severed any relations with the car center or the manufacturer. But now things are different. And this brings back to my topic, from the agricultural economy to industrial economy to digital economy. The industries are changing, including this automobile industry. The industries need to have a huge amount of computing power and cloud and data so as to be able to ride the trend. That's a major change. Another thing is that if we want to use data and cloud, we need to change, and we have seen changes in many different industries, like smart water, smart city. I believe the most popular domain area is what we call new infrastructure in China. The Chinese government have already released policies pushing forward digitalization in many industries based on 5G and cloud. And another impressive domain is the financial sector. In our impression, financial sector is very conservative, reserved. The change is very slow. However, in China, the situation is different. This sector is also pushed forward by the quick development of the internet and the network. Bank 4.0 is a concept proposed for the first time in the market outside of China. However, China is the first to implement it. So today, we're also going to share with you the latest trend in the financial sector. As to new infrastructure, we know that there are three parts, including innovative infrastructure, information infrastructure, and converged infrastructure. The core is about computing power. Now, it is computing power based. We need a center with huge computing power and supply it to many different industries. This computing power center is like the engine. And to do it, we have two challenges. First, we need to ensure there is no loss on the computing power when it is supplied. Computing power is becoming a part of our life, just like the water and electricity. When water and electricity goes to different households, there is a loss. But the loss is not so significant. However, for the loss of a computing power or supercomputing center, the loss can be calculated at the level of hundreds of millions, hundreds of millions yuan or dollars. So we have to ensure that we can minimize the loss of computing power. And the second challenge is about data. In the new year, it's like we are going to have a digital twin for everything. How can we ensure that you can store all the data? Basically, we just store no more than 2% of the data. And the data storage is a slow process. The cameras we notice that are everywhere actually do not have the data in them stored. And besides, the data flow is not so smooth. These are two major challenges. Here on this slide, the left-hand side is the the cloud brain. It's like China is a supercomputing center. In this center, we're going to see AI computing power at the E level. That is about the computing power of around 1 million computers. And in the future, there are going to be a center hosting around 2 million computers. So that means the network is going to play a more important role. The network has to ensure less packet loss. Otherwise, the loss in terms of profit is huge, and it is not acceptable by the supercomputing center. And when there is computing power, we have to ensure that this computing power can be transported to the areas that are needed. In the past, the networking we are seeing are around at 100 GE, but now we can provide the network capacity of around 400 GE. This is what the future network needs to do. And storage flow has to be fast. Perhaps you do not know the current status of the customer clearance. Customer clearance actually requires very high timeliness. They need to do a lot of computing. Now, they have to calculate about the large commodity trading and smuggling to check if there is anything exceptional. To do that, they needed to retrieve a lot of things from the data. And to do that, the customers in China have already switched to full flash array storage. But then there is another catch. They could not successfully pull out of data to do the computing. That is also another problem. You know that Huawei has released the 400 GE AI switches with the AI chipsets in it to ensure lossless computing power, and also 400 GE capacity to ensure the smooth flow of the computing power. Not long ago, I met a customer from the China Construction Bank, and the customer said that the current network only has 32 GE. You know that even traditional companies have already upgraded to 100 GE. The 32 GE can barely help with the storage. Now, with the equal ports, with the Ethernet, the Airbus capability is greater than FC. And with this 400 GE, we can address both storage and computing power issue. If you are interested, feel free to go to our booth to know more. And I also want to talk about the financial transformation in the financial industry. In the past, when I talked to customers overseas, they probably did not have so much impression about that, because in their mobile phones, the only service they can do is about the query. Well, in China, it's experienced the whole process of financial transformation, including the ATM and the online bank. Now, when we go travel, we book all the tickets and the services online. However, the behind at the back end is the financial transaction.
One is the provision is very fast. The CBC client told me in the past it was the provisioning by month, and now it's by week and even by day. So the application is kind of combined and provisioned every several days. Also can support massive access. So it's a kind of a benchmarking with the internet. Maybe in the future the bank can oversee the internet. For example, Tencent and Alipay, and they have only the several core functions. It's different from banks. In the banks, you can see whether it's ICBC or CBC. The major banks, they have more than 95% of transaction made on APP. 95% of the clients has a business or service on the APP. And the banks is not just for financial service. They have different services. They have the service embedded in life. 95% of them is non-financial service. Secondly, for the Bank 4.0, the bank has built many clouds. So how can you have for example, you have more than 10 clouds for deployment. When I asked a client, he told me that they had 16 clouds. You may imagine that one cloud or a public cloud is one cloud. Every 2,000 servers is the ceiling of the cloud. For any big bank or ATT, they have the hundreds or thousands of clouds. So this is about the issue we should consider for Bank 4.0 deployment. On the left side, you can see an example in other countries. So bank is the #1 bank in Russia. We visited the CEO before the transformation of the Huawei service. They had only 2 services provisioning each year, and for each provisioning, it took thousands of people to do that. And then it maintains the same. And now, actually, they learn very fast. You can imagine that it's a #1 bank in Russia. It has about 10,000 people in IT and development teams. They have 1,300 teams for development. And each day, there are many APPs launched. And in Russia, to put it objectively, it has actually had almost all the market share. And in China, we have 4 major banks, but this bank in Russia almost has all the share. And now the business increases 3 times after the transformation. It has a very fast and elastic architecture now. On the right side, you see the example of a Chinese bank. Bank is a very secure and safe sector. The change of the account is in the traditional cloud, and API verification is on another cloud, and the risk control as well as the credit investigation is on another cloud. It's same to customs clearance. After launching one cloud, the virtual machine is aligned, and the networking takes a long time. It's a manual deployment and configuration. If there are many AP, then the efficiency is 10 times different. So how can we have the connection between the network and the clouds or multiple clouds? That will be the biggest challenge at Huawei CloudFabric 2.0 solution. We have the features. One is the network modulates the cloud, just as the traditional one. The network modulates the cloud is about how to connect multiple clouds. The other one is cloud modulating the network. For the clients in the existing networks, they have the equipment from vendors from the US or from other regions. They do not hope it's very complex. So how can we have the management of multiple vendors? And for the downwards, how can we have the multiple vendor compatibility? So there are 2 core issues. One is the network autonomous driving, ADN. So we should have faster deployment and the right deployment from the beginning. So we should have the verification when we deploy the network and check the network to prevent any conflict, and then fast maintenance. So that is a 135 principle. At the booth, you can see the interface. The red dot. We have won the red dot award, and it has the 6-dimensional models. It's quite complex. You can refer to the details on your own. And for the digital twin, actually, the whole network, all the resources are digitalized. And for your intent of deployment and design and the check before launching and the network coordination with the server, we do it. And then if it's okay, then we map it to the network. This is a big change. In the past, it required many people to do the maintenance, and one 1/5 of people are full maintenance for the client at the CBC. So it's a huge manpower and a huge loss. So in the future, we have the 6-dimensional model. In the digital twin model, we can finish all the work. It's suitable for or convenient for faster deployment. Finally, maybe last year you have known the Fabric 1.0, and for the 2.0, we can see the differences from 100G to 400GE. This is one of the differences. We support for each slot 48. For each enclosure, it's 768 by 400GE, so the computing power can flow very smoothly. Also, we have the lossless function. It's very important in the data center FCFB3 networks. Respectively for the storage and computing as well as the Ethernet. So the 3 different networks, how can we put it into one network? Actually, we use a lossless algorithm or solution to have the 3-in-1 network. And even more important, the network is no longer just connecting the computing as a path. In the path, we can have acceleration, computing power, storage, and we can have 30% of efficiency improvement. For 1 percentage, it's about 100 million RMB for the supercomputing. In the past, we had the single cloud. People thought the cloud is virtualized. And for the historically spiral rise, in the past, it was the small cloud. We had different networks, but now for the cloud, each cloud, the ceiling is 2,000 servers. And for big companies, industries, including insurance companies, tens of thousands of servers. So in this case, the resources, we called it a chimney network, and now we call it chimney clouds. For one bank, it may have dozens of clouds. So chimneys are always there. The boundaries are always there. The cloud also has its boundary. So in the past, in the data center, it was the cloud modulating the network. But now we have multiple clouds. We should be dynamic. We have autonomous driving cloud to network to have the connection and alignment among different clouds. That will be the direction for future development. Finally, I would show you the concept of the data center at Huawei. For data center network or DCN, we hope the DCN of Huawei can serve various industries and sectors. We hope the network is not just for connection, but makes it more valuable for computing. Thank you. Thank you, Mr. Wang Lei, for the wonderful sharing. Please take your seat. PICC Property and Casualty is the Fortune 500 company. It has the longest history, the largest scale of business, and the greatest overall strength as a state-owned PICC Property and Casualty company. It's the #1 PC company in Asia, #2 in the world as a single-brand PC company. Today we have the Division of Network Operation, the Maintenance Director, Mr. Wang Jun, to give us a speech. I would like to say thank you to Huawei for inviting me to give a presentation. I'm from PICC P&C, the Network Division Director. I have been in the sector of operation and maintenance of network for more than 10 years. In the past 10 years, we have seen quite a lot of difficulties, and also we have some experiences. I believe you have the similar experience with me if you are from the insurance company. We are a state-owned company. In the past 5 years, the business has been evolving a lot. For example, in the past 5 years ago, to have the claim compensation for car insurance, it took 1 week from reporting, dispatching, the site investigation, and claim settlement. It was about 1 week, but now it only takes 15 minutes. It's not about the simple process. It's about the accelerated process of claim settlement. So we hope the clients can receive their claim as soon as possible. That is the philosophy to serve people at IPICC. Our company, actually, since the People's Republic of China was founded, PICC was also founded. So we have the same age as the nation. The history of insurance has a half developed by our company. And for PICC, we take account for half of the whole history of insurance in China. Currently, we have had some new requirements for further development. We should have the precise management, and we should provide the hot warming service to clients. So we have been engaged in the digitalization of the claim settlement, as well as providing better service to people. We have set up the objective and the plan in the modern era. Here you can see we should provide the coverage accessible in all directions, and we should combine the network, people, and vehicles to become an ecosystem. And also we have the network plus farmland and peak. So that means it's accessible in all directions. Besides, we have a modular architecture. After planning one network, if we want to change it, it's difficult. So we must make sure it's scalable easily, and it's business or service driven, and the process should be visible. For the network, what kind of network we should have, and how can we manage its operation? So for the operators of network, this is a very important point.
And the last point is autonomous driving and self-healing. We have achieved that to a certain extent. Based on these principles, we did 3 things. First, intelligent recognition. Second, intelligent scheduling. And third, intelligent O&M. Actually, they involve different layers of the network. For intelligent recognition, I think there are a lot of things that we need to recognize, including the network applications. We should know the characteristics of the application and the data flow of the applications and the user profiling. All these things are what we care. Only by combining all these things can we really serve the applications well and the customers well. That's about intelligent recognition. And as to intelligent scheduling, it means that for an application in a data center, it may be distributed in different parts of the data center. But the application management part may not know how best it can optimize itself to by being put at a certain part of the data center so that it will be more efficient. Well, for intelligent scheduling, we want to achieve this to optimize the distribution of applications in the data center. And the third, intelligent O&M, we have achieved a lot of progress in this domain. Insurance is a sector that focuses on serving the people. It requires 7/24 O&M, and now the requirement is even higher. If there is even a small glitches in the network, it may incur very major issues. So it's very demanding on the O&M. After a lot of evaluations, we adopted Huawei's Fabric Insight and Telemetry technology to visualize the network and achieve proactive monitoring. On top of this, we also has a major request. That is 1 minute detection of faults, 3 minutes locating, and 5 minutes repairing. Now these requirements have already been realized in our network. And here is a simple example about the application of Fabric Insight and Telemetry. Here, through FI, we apply FI and analyze the 5 dimensions of the network. These 5 dimensions including device, network, protocol, overlay, and service. For these 5 layers, as you can see that they are demonstrated on the dashboard. And these 5 layers each has its own dimensions, and they are presented on the dashboard. Through the AI algorithms, the reports generated in the system can also be analyzed, be interpreted. Around last month, when we handed over from the traditional legacy network to the new network, we found there is a network change, and the data centers, the data library access slowed. So the data center people thought that it was network's fault. However, when we did analysis on the FI, we found out that it is not the fault of the network side. And we helped them locate exactly the time when the data center happened. And the data center personnel checked at that time and found out that it was about their own problem. So we can not only help address the network issues, but also issues in other areas. Another case is that there is no network access available by the external network. So by checking the FI, we found out that there is IP address conflicts. And this is the result we got from the FI. Sometimes FI will tell you or offer you more than one possibilities. If we cannot have this kind of intelligent network and still rely on people on the traditional O&M, just imagine how many people and how long it takes to catch a packet and analyze the problems. Another scenario we encounter is the loop in the network. And I have encountered that 4 to 5 times. The loop in the network means that without knowing, we have configured the network into a loop. And then there is a storm or a problem on the network, and we cannot locate it in the traditional way. Well, through FI, we have such a model to be able to recover the network from the loop within 3 minutes without human interference. FI really helps us achieve autonomous or automated O&M in many scenarios. From 2011 to 2020, in the past years of my experience in the operation center, I ensure there was no major incidents happening, and the team did not grow to a larger size, still with a size of from 7 to 8 people. However, the number of servers has increased by 10 times, and the east-west traffic increased by 20 times. And even amid this kind of growth and amid the evolution, without increasing additional hands, we ensure there are no major faults. In 2014, we achieved the large Layer 2 network, And in 2018, we collaborated with Huawei to set up a SDN network supporting IPv6. In 2017, China proposed the strategy of IPv6, and we moved quickly together with Huawei in 2018, achieved that. In 2019, still together with Huawei, we have implemented intelligent and controllable network. And in 2020, we are working together with Huawei to achieve autonomous driving network. In the future, PICC is still committed to serving the people, and all our capabilities are built to do that. We're still going to work together with Huawei to empower ourselves with technologies, attach an emotion, and give an emotional touch to our service. Thank you, Mr. Wang Jun. Please take the seat. Next, we'll come to the final part. We have a panel discussion around lossless data center. Let's welcome our panelists on stage. They are Mr. Dr. Qi Fashi, the Director of Computing Center at Institute of High Energy Physics of CAS, and Mr. Wang Jun, the Director of Operations Center, PICC. Dr. Wang Shuo, the lecturer of Beijing University of Post and Telecommunications and project leader at Purple Mountain Lab on network communication and security, and also Mr. Wang Lei, President of Data Center Network Domain from Huawei, and Mr. Zhang Bai, Vice President of the Data Center Network, who is also today's moderator. Hello, everyone. I'm Zhang Bai, and we are very honored to have with us those leading experts in this domain to discuss about the lossless network data center. Now in China, the new infrastructure initiative is going in full momentum. The research and the academic circle are working hardly on that area as well. The new infrastructure, including the computing, convergence, and information infrastructure. So for you, the data center-oriented computing infrastructure, how will this computing or data center-oriented computing infrastructure move forward in the future, and what are the major challenges? How about Dr. Qi? Thank you, and thank you for giving me this opportunity to share with you and discuss with all of you about the trend of the DC. And first, about something about the Institute of High Energy Physics. And this physics is focusing on fundamental research. We also are exploring some cutting-edge research. In the very beginning, from the construction to planning to construction to operation, we have installed a lot of large-scale installation. And in recent years, we also have a lot of those large-scale devices in many different parts of the country, including the neutrino collision installation in Jiangmen and other power stations. The significant characteristics of those large devices is that they have a huge amount of data and needs a lot of computing power. So we call it high throughput computing. In this kind of a computing mode, we already have 20 PB amount of data, and each week when we access around 10 PB data. And the volume is keep going up. In the next 2 to 3 years, the data is growing at a rate of 10 PB each day. And we are working with Huawei on the IT planning and design. And now the data volume we're looking at is more than 100 pp. And sometimes we need an output of several giga per second. That means quick input and quick output. Now the algorithms are also developing very fast with the quick progress of software, and we're seeing high performance computing. And we are also promoting the application of HPC in the high energy physics. Now the resources or data resources are distributed at different geographical locations. So it involves the data transfer, storage, and sharing. Internationally, no single computing center can handle this huge amount of computing power. So it needs the concerted efforts of different computing centers from around the world. Computing resources are also distributed. And with the development of AI, we need more methodologies like heterogeneous architecture. As to the requirements on the network layer, we needed to address cross-region networking to enable the quick analysis of computing at different data centers and ensure the high throughput and quick throughput, as well as the meeting the distribution or requirements. So to sum up, we need large bandwidth, ultra-low latency, and on-demand network capacity scheduling, as well as reliability. So network-wise, this is what we are requiring in the new energy, high-energy physics domain. Thank you, Dr. Qi, Director Qi. What about the other two panelists? Well, I can share with you from the network management side.
For the storage or optical fiber storage, it uses FC network. And for O&M, I think it's a kind of a dead end, because with the controllers, we can control all the network and the response. But for FC network, I cannot use it to respond to a situation. I can only use it to resolve the problems. It's not under my control, only the reactive response instead of a proactive response. But now with the lossless network, it can resolve this problem. So we can have the unified management of the network. From the perspective of management, it has the advantage. So we can break the dead end for the network management with a lossless network. Otherwise, as I mentioned before, it has the two separate pieces. We do not have the control over it. So this is from the perspective of management. Okay, thank you. Okay, I would like to take the perspective of research and development. We are from the Purple Mountain Laboratory. In 2018, Jiangsu province established this laboratory for the aim of following President Xi's proposal to establish a national level laboratory. We have the fundamental research and development, and also have the research into the revolutionary applications for different industries. So now at our laboratory, we have a lossless data center, network data center. So we have the research into network itself and also new disruptive technologies for data center. Also at the laboratory, we follow the campaign of the industrial internet. So currently, we are working on establishing the national industrial network. And for the industrial network management system, it will be run in our laboratory in the lossless data center. So these are the two dimensions we should meet the needs. This requires, or this raises different challenges for us in terms of the scientific research. The computing power resources is mainly the CPU resource, but now we have a GPU and the ASIC and all the resources. The computing speed increases dramatically compared with the CPU in the past. It can have 10 times and even 100 times higher speed. So the requirement on latency has a big change. Traditionally, the storage maybe need the millisecond level latency, but now it requires 100 microsecond. So within the lossless network, the computing and distributed collaboration is promising. At our laboratory, we are now working together with Huawei to explore into the autonomous driving network. And for the industrial internet in the future, if we establish the network and there is a lot of corporate data, we know that data is now has the distributed storage, and then we should have AI analytics. So from distributed storage, how can we get the data to the AI system? So this is also has a high requirement on network latency. Thank you very much for the wonderful sharing. Just now we have talked about the data center, whether it's a computing scenario or storage scenario. The experts mentioned the high requirements over the network, high bandwidth, and the low latency and the long-haul transmission. So at Huawei, we propose the solution of lossless network to respond to the future's challenge. I believe you already have some knowledge about the lossless or DCN, and also Dr. Wang already mentioned some of the tests we are working now. And for the lossless network, in terms of technology innovation and also application scenarios, what's your opinions? Before I came here yesterday, I was at Dongguan. At Dongguan, we had the discussion about high energy physics together with Huawei. We already have a half a year's test over the lossless network. The scientific computing is an ecosystem, not just the network. It also has the computing architecture and the software ecosystem. Network is the fundamental layer and platform. Throughout the cooperation with Huawei, in terms of network performance test and application of the lossless network and currently the results of the computing performance and application performance is quite good. We hope in the future we adopt the rocket protocol to realize the cross-region and long-distance lossless network transmission. From the initial results, we can see it can meet the current needs and demand. In the future, we will see more tests. We may identify some problems, but however, this is a clear direction for our future work. Thank you. Dr. Wang, for the lossless network, as a research institute, we actually pay attention to it for a long time. In the data center, the lossless, at the beginning, it uses a TCP protocol. and now it uses packet loss in the network to control the signal. At the beginning, only 1G, and now 10G bandwidth. Based on DTCP and relatively new TCP control protocol, when it reaches 10G, it exposes some problems. And now with the AI application, when the network upgrades to 40 to 100G, if there is transmission of AI indicators, then the small packet transmission, the speed cannot be upgraded. And for the TikTok application, it's based on AI recognition. It requires the synchronization of AI parameters, how to improve the speed of training. This is a new bottleneck. With the further development of technology, we have a lossless network and a Rocket protocol, PFC proactive announcement approach to realize the network latency reduction. So with this technology, it can support the TikTok application and beauty cam and all the emerging applications. And with lossless network, all these applications can have a massive training. So this is an important value of lossless network. It's not just about technology disruption and innovation, and for application model and for people's lives, it gives us much more convenience and more value. Thank you, Dr. Wang. For the intelligent lossless network, and with the new infrastructure trend and the challenge and the technology innovation applications of lossless network, we already touched upon them. And in the following time frame, for the lossless network, we would like to talk about the evolution of technology and the application of a lossless network in the future. Recently, as I said before, we have the comprehensive cooperation with Huawei to proceed the development of a lossless network. For the high-energy physics, we are a user of this technology, and Dr. Wang mainly talked about the technology development and the technology disruption. And for us, we mainly focus on the application. We hope a lossless network is not just used in high-energy physics for computing. We hope that the technology can accelerate the efficiency of computing. So in the future, we hope together with Huawei and the relevant parties, we can have a further analysis into the features of the lossless network and traffic, so that we can have the technology for storable technology, and in some applications, for example, online computing and offline computing, we can have the scenario for that. So for the network, it's not just for communication. Instead, the network can reduce the load of data computing and processing or moving. And it's an integrated system. It has a storage and a network. So we should have the coordination and have the comprehensive use of lossless network to speed up the data processing. We hope in the near future we can have a deeper cooperation with Huawei in this regard. So the future is promising. Thank you. Dr. Qi? Okay, I will share my view from the viewpoint of technology. The lossless network has several trends. Firstly, the lossless network has already dramatic improvement in performance, but for the operation, it has some more parameters, including PFC and ECM parameter configuration. we should follow different situation. The demand for the configuration is also strongly correlated to the speed. 40G and 100G, the parameters are different. I'm very happy to see that Huawei's autonomous driving network, one important technology is AIECM adjustment or modulation. That is an important development trend. How can we use AI to configure the network's parameters, complex parameters, to simplify the manual procedures and simplify the management? So this is a very important direction for technology development. The second trend is IDMA and the rocket network. O&M and forward management is a headache. With the IDM technology, for example, we had quite a lot of problems, and it's difficult to locate the faults and the fault of the switches or the faults in the data center. So to locate and analyze the fault is another important trend of development. With the development of cloud technology, we need to locate the faults in switches, but now with the data center and the tenant concept, so we should locate the more faults, and this is something we should resolve with the technology. And telemetry and NT and other new technologies can help us to have the packet-by-packet analytics, to have the automated prediction and the warning or alarm of the faults. These are important trends of technology. We would like to have Mr. Wang Lei to give us a summary. Okay, I would like to share my personal opinion before wrapping up. I tried to grab the microphone, but failed. The experts, Mr. Wang and Dr. Wang and Mr. Qi, they have a really good, excellent sharing, whether it's research or finance or the network application in the future. I think yesterday, Mr. Ho asked me in the data center how will be the 3D networks developing in the future. One is the FCC for storage, Ethernet, and the IP for computing network. And FCC network has a kind of dead end. Each year is about 12 billion scale. And for the dead end, we should break it. And this morning, I met a client from Shanghai Supercomputing. IP is even worse than that. It's not visible.
And even if they found any issues in the supercomputing center, they could not maintain by themselves. They need the support from the U.S. suppliers. That's an even bigger breaking point. From the network construction to maintenance, a visualized network should be a comprehensive Ethernet network. In the future, Ethernet network is not about connectivity. It's also about storage and computing power. And all the three aspects will be connected, and the computing performance will be increased to form the next generation network to serve the financial sector as well as the high energy physics. That's why Huawei made such a heavy investment in this domain. Thank you, Mr. Lei, for all the sharing.
They can say it all sounds crazy. They can say we've lost our minds. I don't care if they call us crazy. Run away to a world that we design. Every night I lie in bed, the brightest colors fill my head. A million dreams are keeping